All right, welcome back. Let's actually take a look at an example here, and I think this will really help you understand how the ratios work. Okay, we're looking at a brown triangle on the screen. Excuse me. And the triangle is marked. It's got a 30-degree angle there. We know two of the sides. And I just want to bring up a convention that we use often in trigonometry here. If you take a look at angle A down at the bottom, which is 30 degrees, angle A is 30 degrees. If you look across from 30 degrees, the opposite side, you'll notice that that is labeled lowercase a. And if you look at angle B, for example, if you look across from angle B, that side is labeled lowercase c, and then the other one would be this is lowercase b, the other one is lowercase c. And what we do in trigonometry often, because we're always talking about the opposite side or the adjacent side or the hypotenuse, we get into this habit of organizing ourselves so that when we're talking about an angle, any angle you want, like if you're talking about angle F, the side across from angle F will be lowercase f. So we get in this habit of doing lowercase letters for sides, and capital letters for angle. And the letters are the same letters, it's just whether it's uppercase or lowercase. So that's a nice convention to keep things straight for us. Alright, so let's actually see what we can do with this triangle. If you remember your geometry, a triangle always has 180 degrees. That's the sum of the triangle theorem, sum of the angle theorem for a triangle. And if you add up to all three angles, you'll get 180. So in this problem, we know 90 degrees, we know the 90-degree angle, we know a 30-degree angle, so simply by subtracting, we get the other one must be 60 degrees. So we know all three angles now, just using simple subtraction. Now I want to draw your attention to the 60 and the 30 for a second. The 60 and the 30 add up to 90 degrees. And one more geometry term for you, if you remember correctly, when you have two angles that add up to 90 degrees, those are called complementary angles. Complementary angles. And we say, for example, angle B is the complement of angle A, and angle A is the complement of angle B. The nice thing about a right triangle is because one angle is always going to be 90 degrees, the other two angles must add up to 90 degrees. So you really just have to worry about, if they give you a 30-degree angle, you can just do 90 minus the 30 to get the other angle, which is a nice way to back into it. So complementary angles, two angles that add up to 90 degrees. Okay, now that we know the angles, we know all three angles of the triangle, we know two of the sides, it's time to go after the third side. And this has nothing to do with trigonometry because we can just use the Pythagorean theorem, a squared plus b squared equals c squared, to figure out that missing side. And just remember that the hypotenuse is always the longest one, that's the c squared part. So when we set up our equation, for this problem we get 3 squared plus b squared equals the c squared, 6 squared in this problem. The rest of this is just going to be to isolate b, figure out what that missing side is. So we do the arithmetic, 3 squared is 9, 6 squared is 36. We subtract 9 from both sides and we get b squared equals 27. We're not interested in b squared, we're interested in b, so we take the square root of both sides. And here I just want to draw your attention to the answer is the square root of 27. That's the exact answer. If you remember correctly, early in the year we simplified radicals. And inside of 27 is a perfect square, 9. 27 is the same thing as saying 9 times 3. And since we know the square root of 9, we take that out. And the answer, the exact answer is b is 3 times the square root of 3 feet long, which is a bit awkward to say, but that's the exact answer. So if you take your graphing calculator, and I have one right here on screen for you, if you take your graphing calculator, we can simply do the arithmetic, 3 times the square root of 3, and when you press enter, you'll realize that the b is approximately 5.2 feet. So now you know all three sides. So 5.2 feet is approximately for b. The better answer, the best answer you can give is 3 times the square root of 3 for b. Excuse me. Okay, that takes care of all the sides. This is what's known as solving a triangle. When you figure out all the angles and you figure out all the sides, you've solved the triangle. You've pretty much told me everything there is to know about it. In fact, we really don't need trigonometry at all for this problem because there's nothing else to solve. We know everything there is. Now we are going to use trigonometry. We're going to use the three ratios just to show you where they come from and what the values would be, it's nice to start off with a triangle we know everything about, and then we can go figure out the ratios. So let's do that now. Let's move on to actually figuring out what the ratios are. So on the screen, you have the three ratios at the top for you, just to organize them. SOHCAHTOA, that's how you want to remember those, SOHCAHTOA. And here's a triangle that we just worked with. I went ahead and put in the b, so the b is 3 times the square root of 3 feet. That's the exact answer. And now we're going to work our way through the ratios. So let's start with the sine. The sine of theta. Now theta represents the angle you're looking for. Well, which one do you want to pick? There's 3 of them. There's 30 degrees, there's 60 degrees, and there's 90 degrees. Which one are you going to go after? The answer is, it depends on what you're looking for. It depends on what side you need to solve for to figure out which one you want. So in this problem, we're going to get both of them, but just keep in mind that which angle you pick, which one you get the sine for, depends on what you're missing, and then that's coming up later. So right now, let's just focus in on the 30 degrees. We'll just pick the 30 degrees, and we're going to find the ratios for the sine, cosine, and tangent for the 30 degree angle. So the first thing we do is we have the 30 degrees. Sine of theta, the sine of A, is defined as the opposite side divided by the hypotenuse. So this would be 3 divided by 6. And sure enough, that is what the answer is. The answer is the sine of 30 degrees is 3/6. And then we just simplify that to say 1/2. So the sine of 30 degrees equals 1/2. Now here's where the similarity part kicks in. Every single triangle that has 30, 60, and 90 degrees in it, every single 30, 60, 90 right triangle in existence will have the same sine ratio. Every sine of 30 degrees, no matter how big or how small that right triangle is, every single one will be 1/2. The opposite side will always have a ratio to the hypotenuse of 1 to 2. And that's because of similarity. If you grow this triangle, you make it bigger. Instead of 3 feet over here, you make it 12 feet. You've grown it by 4 times. It's increased by 4. The similarity ratio would be 4. So if you grow that triangle to say 12, well, the hypotenuse also grows by 4 times. The hypotenuse now becomes 24. Well, the sine of 30 degrees, it will still be 30 degrees no matter how big you make it. It's still going to be the opposite over the adjacent. If I grow this one, if I grow the 3 feet to be 12 and I grow the 6 feet to be 24, it's still 12 divided by 24, which is 1/2. So this is a good place for me to introduce a graphing calculator and how you're going to use it in trigonometry. So on your graphing calculator, you may want to do this with me as I go along. Clear out the screen. Now there's really one important thing that you have to learn about the graphing calculator. In Algebra 2, we just work with degrees. There's something called radians. It's another way to measure angles. You will have to learn radians when you take trigonometry in a full year course and when you take pre-calculus. But for Algebra 2, we're just trying to introduce the basics. So we're not going to use radians in this course. We're going to stick with our degrees that we know well from geometry. Unfortunately, your calculator is set up to default to radians. It thinks you want to work in this other system, the radian system. You know, it's kind of like metric and standard. So you have to change your calculator. You have to make sure your calculator is in the right mode. So the first thing you need to do on your calculator is find the button called mode and go ahead and press that button, and there's a lot of options in there. We really just want to concern ourselves with the option that says radian in degree. Do you see it? Radian in degree right there. So right now your calculator is in radian mode. Use your arrow keys. Go down to highlight degree, press enter. That'll enter your calculator in degree mode. And now any calculation you do will assume you're working in degrees. So now let's get out of the screen by doing second quit. And now we can go ahead and do the calculation. The sine, S-I-N, stands for sine. Don't say sin. The sine of 30, it's waiting for the angle. I'm telling it the angle. So the sine of 30 degrees, because I'm in degree mode, it knows I'm talking about degrees. If you press enter right now, it gives you 1/2. 0.5 is 1/2. You can press the math button, and turn it into a fraction if you like. And there's where the 1/2 comes from. And no matter how big that 30, 60, 90 right triangle is, if it has a 30-degree angle, the opposite side compared to the hypotenuse will always be 1/2 regardless of size. That's really important. That's really the basis for trigonometry. So the similarity part. Alright, so that's the sine. Now we can move on to the other ones. The other ones fall pretty quickly after that. So let's look at the cosine now. And the cosine of 30 degrees will be the adjacent side, 3√3, divided by the hypotenuse. So you're dividing it by 6. And the only thing you have to do here is just simplify this fraction. So 3 and 6 simplify to 1 and 2, and then your final answer is square root of 3 over 2. That is the exact answer, and that's what we use. If you wanted to get the estimated answer on your calculator, you could go cosine of 30 degrees, and the calculator will give you an approximation. The calculator cannot give you the exact answer, so you have to be able to do this without a calculator. Because if I try to convert this to a fraction, the calculator will come back and say, no can do. There's no way I can convert that. It's irrational. And that's because the square root of 3 part of the fraction. It can't do anything with that. It's irrational. So the answer, the best answer you can give me is square root of 3 over 2, and that's what you need to give me on the homework. You can't give me the estimated number. Okay, and then the tangent, same thing for the tangent. The tangent of 30 degrees is going to be the opposite side, 3, divided by the adjacent side, which is 3 times the square root of 3. The only thing you have to watch out for in this problem is that you can't leave a radical in the denominator. You have to fix that. So you multiply the numerator and the denominator by the square root of 3. That gets rid of the denominator in the bottom. You end up with a 9. And the top gets 3 times the square root of 3. The 3 and the 9 can be simplified to square root of 3 over 3. And there you go. That's how you do it. Now, that's 30 degrees, right? That would be 30 degrees. You have to do the same thing if you were interested in getting the 60-degree angle. Because how do you know you want the 30 degrees? How do you know you weren't after the 60-degree angle? Well, you go through the same situation, the same steps that you just did for 30 degrees. First, you find the sine. You go opposite side. Opposite side is 3 square root of 3 divided by 6. That simplifies to be the square root of 3 over 2. Do you notice that that answer is the same answer as the cosine of 30 degrees? Those are called cofunctions. More on that later, but that's not a coincidence that those two answers are the same. It has something to do with the CO. Okay, moving on to the cosine of 60 degrees, you would do, here's a 60. The adjacent side is 3. The hypotenuse is 6. 3, 6, 1/2. That answer is the same as the sine of 30 degrees. Not a coincidence. And the last one, the cotangent, you find 60 degrees. It would be the opposite side. I'm sorry, cotangent is the adjacent side divided by the, I'm sorry, I'm getting myself confused here. I was thinking the reciprocal functions. The tangent of 60 degrees is the opposite side divided by the adjacent side. Sorry about that. So 3 root 3 divided by 3. The 3's simplify, 1 over 1. That answer is just the square root of 3 all by itself. Alright, so this is your first example of how to solve for the ratios. I'm going to pause here the video before I begin another example to make sure you understand what's going on. The next one's going to get a little more complicated. But these are the basic steps. You really just have to, 1, find the missing angles, and then 2, set up the ratios based on the SOHCAHTOA. Which angle you need determines how you set it up. Whether you want the 30 degrees, you're going to go this way, opposite over hypotenuse for the sine. But if you wanted the 60 degrees, this would be the opposite, and then you'd do it over the hypotenuse. Okay? See you in the next video.